Welcome to another tutorial video. In this video, we'll be exploring material analysis of concrete M15, which comprises of a mixed ratio of 1:2:4, that is 1 earth-pound of cement, 2 earth-pounds of sand, and 4 earth-pounds of aggregate. Estimating the quantity of different materials in construction projects helps to give the stakeholder an idea of the quantity of different material required for a project. Make it easy to plan for same and to have the project cost estimated perfectly and arrangement for funds in advance will in turn lead to a smooth flow during the execution of the project, and the project can be completed within stipulated time and budget, and also provide value for money spent to the client. Before we dive into today's video, if you enjoy my content, kindly subscribe, like, comment, also turn on the notification bell so as to get notified anytime I drop a new video. With all being said, let's get into this video. Cement density 1440 kg per meter cube. Sand density 1600 kg per meter cube. Aggregate density 1800 kg per meter cube. Dry volume constant 1.54. Concrete mix ratio 1:2:4. Why 1.54? Concrete wet volume can be converted to its dry volume by using a factor of 1.54. By converting wet volume to dry volume, we get a 54% increase in dry volume, so we can calculate how many material are dry. Divide 1.54 concrete calculation. Dry volume equals to 54% of wet volume plus wet volume. Dry volume equals to 54 divided by 100 multiplied by 1 all bracket plus 1 equals to 0.54 plus 1. We have 1.54. Therefore, to make 1 meter cube of wet mix concrete, we need 1.54 meter cube of dry mix. For cement, we need to add the mix ratio together, that is 1 plus 2 plus 4 equals to 7. So 1/7 multiplied by 1.54 multiplied by 1440. We have 316.80 kg. 1 bag of cement equals to 50 kg. Therefore, to calculate the total number of bags required, weight in kg divided by bags per kg, that is 316.80 divided by 50. We have 6.336. Therefore, we have 6.34 bags of cement in 1 meter cube of M15 concrete mix. Sand 2 divided by 7 multiplied by 1.54 multiplied by 1600 kg per meter cube. We have 704 kg. To convert to tons, density in kg divided by 1000, we have 0.704 tons. Therefore, we have 0.704 tons of sand in concrete grade M15 mix. For aggregate, 4 divided by 7 multiplied by 1.54 multiplied by 1800 kg per meter cube. We have 1584 kg. To convert to tons, density in kg divided by 1000, we have 1.584 tons. Therefore, we have 1.584 tons of aggregate in concrete grade mix M15. This method can be used in calculating material analysis of any concrete mix, just that you need to confirm the mix ratio and substitute where applicable. Until when next, I'll be seeing you in a new tutorial video.